I'll be right back. Okay. Let's see, a reminder that homework. Let's see, the quiz for 04 is due, I think, today. Lab materials are due today. At the end of next week is when you start, there's a little bit of a time crunch because homework 3 is due Friday and P2 is due that Monday. So, you know, you're going to want to use your time wisely. Try to work some of that stuff now, earlier in the week instead of waiting for the end. Because if you get behind at the end of the week, then you won't have any time to catch up. I wanted to talk about the P2 deliverable. I have some examples. The format has changed a little bit from the time these examples were made. But the idea here is, let's see, let's do this. Here's the assignment description. And I'm saying that it's, you know, it's an 8 to 12 hour task. It's not a trivial task. And the reason is you have to think through all the functionality of your project and describe it. One of the comments I made over and over on the P1 deliverables was that people would say, I'm going to have a button that does this and a button that does that, or I'm going to use the arrow keys to do this. And that's good. You need to have that kind of visualization. But in the P2, you don't want to express it that way. So if you're allowing a character on the screen to move left, right, you know, north, south, east, west based on arrow keys, that might be your intent. But in P2, all you need to say is you want the character to be able to move north, south, east, west, and don't specify how you're going to make that happen. You don't want to embed the design in the problem statement. So the idea behind how software gets developed is I, as the customer, might say, I need the software to do this, and then it's the design team's decision as to how to make it do that. So the problem description or the description of the functionality of the software doesn't include the specifics of how things happen. Now, if it is absolutely critical that that become a requirement that things have to happen in a particular way, then you put it in there. But as a general rule, you want to describe what you need done, not how it gets done. So that's the focus on the P2 deliverable. There's a couple of documents. I give you this software design document template. Put in your project title, don't turn it in with project title. Put in your name, don't turn in with student name. Put in the date. You can call it a software design document Rev 0 or draft or whatever you want to, because you will be updating this. The introductory section simply just talks in general terms about what the software is doing, why someone might want this thing. My belief when you're writing a document as early as possible, tell the reader what the document is doing and why. Sometimes the whys here aren't that critical. Lots of people have chosen to make games. Well, it's hard to justify a why for that, okay? So some people are doing analytical models, And you can talk about why for that, because an analytical model, I don't know, that is looking at evaluation of some business model, well, that has a use in the business community. That has a use in directing investments. But a game, well, why? It's enjoyment, maybe a personal challenge. This is the heart of the P2 deliverable, is the problem description. And again, talk about what you want your project to do, not how it's going to be done. Now, if you're developing a game, then you need to have all of the details of the game, all of the rules, all of the movements that a character can make, all of the components. Try to think, that's why it's an 8 to 12 hour task. Try to think deeply about what this thing is going to include and what it isn't going to include. If you're doing simulations of some process, the same idea holds. No simulation contains everything about a real world process. So you might want to describe and justify what you included and what you did not include. I talked last week in tech writing that when you want to use a term, you define what that term means. So so you try to make it where that term is not ambiguous. And then you use that term over and over and over again. If you are calling let's say you're developing a game and you're calling the place where the game is played out the playing field, then make a brief note, that this will be called the playing field, and then always call it the playing field. I tend to call it field of play. The area will be in an X by Y sized field of play, and then I'll use that term all the time, field of play. If you are doing physics simulations, you probably have some formulas. Include the formulas. If you are doing a game where people do attacks and take damage, this is the place to define that. Several of you are saying, I'm going to have a game and people have weapons and they can choose between the weapons, and the weapons do different kinds of damage. Make those definitions here. You're not saying how you're going to achieve that, but you are saying what is being done. One good way to think of a game, and again, a lot of you are doing games. One good way to think of a game is, what if I had to play this on a physical cardboard board with physical pen, physical dice, physical pencil and paper, physical pieces? What rules would I need to tell someone if they were going to play this game with me? And you need that many rules in all the rules and options in this description. So it's not trivial. And the reason is you want to get as full a functional description of what this thing is going to do before you start designing it and before you start coding it. The next section has user stories, and these are just a listing of the user stories. The actual user stories I'll flesh out more in the other deliverable that you have, the Agile tracking sheet. And then problem solution, this is not done now. This is going to be, draft version is in P3, not in P2. So you can leave this exactly like it is, or you can do this. Just keep it as a placeholder, but keep it. Don't delete that section. When I say use this template, that's what I mean, use this template. So don't delete that section. You can note that it won't be completed or it won't be filled in until P3, and that's fine. And that's a normal way to create documents. You create the skeleton form of the document and you just put notes in as to what parts are not completed. Virtually all of you will have references. Whoops. So provide the reference list. I don't care what format you're using. If you want to use APA or Chicago or IEEE style, that's fine. Off the top of my head, I don't know that I saw people that wouldn't have these. Most of you are saying, I'm going to create a game similar to, and that means that you need to have some kind of a reference for that game. The online access portal for the game is not the reference for the game. Somebody has written something about that game. And ideally, you would have a magazine article about it, or you would have the advertising information or the game information published by the company that publishes the game. Those kinds of things are helpful. And ideally, you would find something that exists external to the internet. So if you want to use maybe a gaming magazine gives a review of that game, you can use that, because the gaming magazine exists outside of the internet. Even if you accessed it online, the thing is persistent and exists outside the internet. Web pages come and go. The whole point of a reference is that someone is able to go to that reference and read that reference and verify that you reflected accurately what was in it. And if a web page disappears, that can't happen. If a web page gets modified, that can't happen. That's the big thing about, you all know this, don't use Wikipedia as a reference. It's not because Wikipedia is wrong, it's because it can be modified. And if it can be modified, then the information that you used can disappear. So again, try to find something that is a persistent reference so that it will never disappear and people can go look it up. And then optionally, you may have appendices. So if you have a situation where you're including a lot of data, maybe you have appendices that talk about where you're getting that data from. If you have appendices, if you have a situation where, some of you guys are doing like role-playing game character trackers, maybe you could put a paper version of what a character sheet looks like there, and then refer to it in the problem description. Before we move to the Agile tracking sheet, I'm going to pause for questions.
If we're to use like a certain type of well-established algorithm, like pathfinding or something,
yeah,
are we supposed to cite that?
Yeah. And you'll find it in any data structures and algorithms book.
Okay.
Or if it's a really obscure algorithm, some people do algorithms that are kind of novel or really fancy. Whoever created that algorithm will have published it in a paper, in a conference or a journal paper. So you can find those. And there are journals, the Journal of Algorithms put out by the ACM. There are people who, some of you guys are doing machine learning, like genetic algorithms or neural nets. You can find what you need either in textbooks, and often you can find PDFs of those textbooks, and you can also find what you need in published conference papers. Don't necessarily go to Google, go to Google Scholar, and they give you books and papers. Other questions? I think it's better to be overly cautious with references than not. If you're doing physics and you want to use the formula F equals ma, well, everybody knows that. It doesn't hurt to add a reference to a physics book about that. Okay, these user stories. I'm asking you to do this Agile tracking sheet, and there's a couple of reasons for it. One is I'm introducing you to bits and pieces of the Agile Scrum process. We can't do it all because it's a team process and you're doing individual projects, but I can give you parts of it that make sense for an individual. And the way the Agile process works is you get some kind of a description from the customer of what they want. And from there, you create what are called user stories, where each user story describes a piece of functionality of the system. And then each user story is used to set up how you're going to do the work. So you take each user story, you estimate how long you think it's going to take to do it, and then we do these sprints. You know, a sprint is just a short period of time, and at the end of that period of time, you have functional code. It doesn't mean it does everything, but it does function, and it does some things. And what you do is you pick the user stories that you want to complete for each sprint. And again, normally that's a team type process, but as an individual, you can still do it. So I have this Agile tracking sheet, and it's got 3 parts. One is where you fill in your user stories, and I'll go over that. I do have an example for this. And then you start out with, okay, here's all my user stories in the backlog, except for the ones that I'm going to work for the first sprint. Once I start coding, these are the first user stories I'm going to complete. And that's going to be your P4 deliverable. Is between P3 and P4, that's your first sprint. And after P4, when that's done, you're going to enter the second sprint. And now you take the backlog. That's all the user stories that are left, except minus the ones that you're going to work now in the second sprint. And whatever you completed in the first sprint, you put here. So if you say you're going to do user stories 1, 2, and 3, and then you completed 1, 2, and 3, you put those here. So what's happening is you have a way to track for each sprint what's on the table. What do you need to focus on? Rather than trying to think of, oh my gosh, I have this giant project and I don't know where to begin and I don't know how to start. What you're doing is you're breaking it up into little bite-sized chunks. So each one of these becomes a relatively small task. You know, ideally it's a small task. One of the things I'm asking you to do on your homeworks and P1s is to give feedback on how long it took you to do these things. But so these surveys are popping up. When things are due, the surveys will pop up for 2 days. You know, I give you extra credit for filling those out. It's one question. How long did this take? How many hours did this take? And the reason I'm doing that is twofold. One is I want to know how long it takes so that I make sure in future semesters I'm not overly burdening students. And the other thing is you should know how long it takes so that when you're asked to do a task in the future, you can say, okay, that's going to take me 5 hours. I can do that in 20 hours. I can do that in 2 hours. So you can start to get a feel for your own rate of productivity. So I'm asking you to fill in the user stories, this notion of completeness criteria, what the effort is, and then from there you can estimate up front, you estimate over here what sprint you're going to work it in, and then, okay, for the first sprint, I take all 12. I'm asking for 12. You may have more. I take all 12. I'm going to do the first 3 in the first sprint. So this is going to have 4, 5, 6, 7, 8, 9, 10, 11, 12. This is going to have 1, 2, 3. And if I finished all 3, then I'm going to do, say, 4, 5, and 6 in the second sprint. This will have 7, 8, 9, 10, 11, 12, 4, 5, and 6. And up here under completed, the sprint is 1, 2, 3. What happens if you don't complete a sprint? You move it to the next sprint. You reprioritize. The priorities, I'm just listing them as 1 through 12. There are not allowed to be any ties. You have to have a sequence. And then lastly, this burn down chart. Under planned, all you do is you add up all of the hours that you think each user story is going to take, and you put that number there. This is going to take me 60 hours. And then down here under 7 December, which is when everything is due, you put in 0, and then you evenly distribute those hours. So it's going to be 60, I don't know if this will work out, 50, 40, 30, 20, 10, 5, 0. Make it work out even. What is this? 60 is going to be 50, 52, 44, something like that. Then as you go on after each sprint, you actually fill in based on the work that you have left, how much effort do you have left? That way you're keeping track of, are you ahead of schedule, are you behind schedule? So the whole process here is about breaking things down into small bite-sized chunks, doing the most important ones first, always having functional code, not complete code, but functional code, and always keeping track of how much effort you have left to get this done. So if you go into Thanksgiving, here we are on 23 November, just before Thanksgiving break, and the plan says you should have 15 hours left, and you think 30 hours left, that tells you something. It tells you you're gonna have a miserable Thanksgiving. On the other hand, if you have 8 hours left, right, then you're in pretty good shape. Now remember, we don't have classes after Thanksgiving, so you'll have time to, in theory, have time to work on this stuff. This whole process, though, is trying to get you to avoid the, well, I have all that time after Thanksgiving, before December 7th, so I'm not going to do anything until Thanksgiving. Because that's a recipe for failure right there. So what this is forcing you to do, take your work into bite-sized chunks and spread it out evenly over the time that you're supposed to get the work done in. Yeah, I'm always here. Yeah, I'm always around. Yeah, during that time, Thanksgiving Day itself, I don't know what's going on, but during that break, and then, we don't come back for classes, they're all listed as study days. And so, yes, I am available all the time during those study days. As is, I'm sure, Dean. The rest of this is just the instructions. Remove the instructions before you, what is happening? There we go. Okay. Remove the instructions before you turn in the Agile tracking sheet. And then each sprint, so in P2, you're going to deliver this basically as a plan. And then in P4, 5, 6, and 7, you're going to be delivering it showing progress. And I have an example here. Let me see if I actually have it brought up. There we go. So remember the sheepdog game. I made an Agile tracking sheet for that. This is how I would plan it out. The sheepdog game, right? So I give it an actual title. And I said, this is Rev 0. This is my first submission. It's a draft, today's date, and I'll just keep changing that as I go through. And filling in the user stories, let's talk about those. They look like this. As a blank, I want to blank. And do that form. That's the accepted form. As a blank, I want to blank. Now, sometimes if you go and read about Agile work, and it's online, it's not hard to find. It's as a blank, I want to blank in order to blank, and I'm leaving that in order to blank off. So as a developer, I want to have a functional system for testing. I thought that should be my highest priority, is to do this trick that I'm talking about, where I have all the classes that I think I need exist, all the attributes exist, all the methods exist, and they all do nothing, right? The methods do the returning of the dummy values and printing out somebody called me, like I showed you in lecture the other day. So that's what I think is my first step. As a developer, I want to have functioning system for testing. And then I have to say, okay, how do I know that I completed that? Well, all the classes are present with dummy methods. GUI classes may be undeveloped. So I'm allowing myself a little leeway, because the GUI classes are sometimes are a little more experimental, let us say. You kind of have to play with it as you go. So they may not be fully there. I'm going to allow myself that. And I think that's going to take 3 hours. And then that's priority number 1, and I'm going to work it in sprint. So all I do is I list these. And by the way, the priority and the user ID, destroy ID are going to match, because that's just how I created them. I didn't even number them until I prioritized them. So as a developer, that's what I want. But then I can say, oh, as a player, I want to be able to see the sheep, dog, and terrain, right? The player should see what's happening on the in the game. So as a player, I want to be able to see the sheep, dog, and terrain. And now I'm saying, okay, all the visual elements appear on the GUI. Now notice the phrasing, all of them are there. Can I move the dog? No. Do the sheep move? No. They're just there, sitting on the screen, ignoring me. So this is what I mean by breaking things down into small chunks. Now, the sheep-sheepdog game is so simple. Quite frankly, it's hard to come up with 12 good user stories. A lot of you guys are going to have no trouble at all coming up with user stories. And again, I've had students turn in 20, 30, 40 user stories. That's fine. So as a developer, as a player, I've got one here as a game designer. I want to limit the dog movements to the field of play. Why is that as a game designer? Again, you consider the roles that are happening here. As a developer, I don't care, right? If a game designer came to me and said, develop this game for me. Okay, I'm a developer, whatever you want. Can the dog shoot off into space? You know, as a developer, I don't care. As a player, I may not care. It may be annoying, but I may not care. So I chose to frame that as a game designer. As a game designer, I want to limit the dog movements to the field of play. As a developer, I want the sheep to know where the dog is at all times. Right? So I'm doing these things, and then I'm giving out, okay, notice I didn't say what the mechanism was. Mechanism exists to provide the sheep the location of the dog. I'll have to test that, right? I'll have to actually convince myself that that happened. I broke up. As a player, I want to be able to move the dog in any direction. As a player, I want to be able to control the speed of the dog. How do I know it's done? Oh, okay, user was able to increase the speed to the max speed and reduce to 0. Now, that's not a visual test on the screen. That can turn into an honest to gosh real test case like you guys have been handling in homework 1 and 2 and now 3. Okay, so once I do these user story completeness criteria, then what I did is I thought about priority. And so I did have these in a different order initially, and then I rejiggered them in order to just put them in priority in the sequence that I wanted to work them in. So then I've got my priorities 1 through 12. Again, you're not allowed to have any ties in the priority. And then I just took a swag at how long I think this will take. I went through my classes, and again, I don't have a design yet, so it's a little tough, right? I don't have a design yet, but I think I have a feel for how many classes I need. You know, I think I'm going to need an animal class, and then I'm going to extend that to the sheep. I'm going to extend that to the dog. I'm going to have a terrain class, so there's 4 classes. I'm going to need a controller class, so that's 5 classes. And then I'm going to need the top-level GUI class, which I think is going to contain, based on my experience with GUIs, about 1 non-trivial class in it. So that's 7 classes. And again, all I'm doing is you know, I'm not actually coding anything. I'm just laying in attributes and methods. So that'll probably take me about 3 hours. Remember, I'm going to plan for what those attributes and methods are in P3. So some of that work will get buried there. So I figured, okay, I went back and I looked at, okay, sprint 1, I think I put in that my estimate is you'll work about 8 hours. Sprints 2, 3, and 4 were about 10 hours each. So then I went through and I said, okay, I want to put in less than 8 hours for sprint 1, less than 10 hours for sprint 2, less than 10 hours for sprint 3, less for 10 hours for sprint 4. And I just smoothed out the work there. Now, what happens if you're in here and you're saying, oh gosh, this is going to take me 8 hours, and the next one's going to take me 12 hours, and the next one's going to take me 6 hours. What you might need to think about is that you're putting too large of a scope in your project. You might need to simplify your project. You can get away with making things simple now, and then after the semester, you can flesh it out. And I made that comment on several of y'all's P1s where you said, you know, I'm going to do this big sophisticated thing. Okay, that's great, but maybe what you do is you create the framework now, and then you're going to have to do a whole lot of content creation. So you can wait till after the semester to get the content creation. You're going to get the framework in now, everything works, and then the rest is you need, you know, 1 million data points, or you need, you know, a whole lot of different descriptions for rooms in a dungeon or something like that. So if you're finding that your hours estimate is, you know, there's no way I'm going to be done by the end of the semester, that's telling you something, and it's okay to listen to that. This one sounds simple, right? Game designer, I want to be able to pause and restart the game, and I gave myself 3 hours for that. And the reason is I haven't worked that much with the Java timers, and so I'm assuming that I'm going to have some issues with the timer. So, you know, be aware of try to be aware of your skill set. And again, you'll learn, right? You can go back after your first sprint and adjust these hours. You have, as you're creating these, a notional idea of what these design might be. Like I just gave you what I think my classes will be, and it's okay to be wrong. These are just good estimates. Now, how do you get to where these estimates are really accurate? You spend 10 years in the software industry. You know how it is when you're developing software. The thing you thought was going to take an hour might take 5. The thing you thought was going to take 2 hours, maybe it only took an hour. Unfortunately, the first example is the one that always happens. Okay, then I set myself up for my first sprint. I'm only going to do a 1 and 2 in the first sprint, and that means that my backlog is still everybody else, 3 through 12. Completed the sprint? Well, so far I haven't completed anything, right? At the end of the first sprint is when I'm going to put that in there. And then I added up all my hours, 24. That feels light. And I just evenly distribute them. I used integer values, so I you know, wiggled left and right. If you want to put in decimals, that's fine. 24 hours, so at the end of the first week, I should have 21 left, and then 17 left, 14 left. All I did is evenly distribute it. That's my plan. And currently, how much work do I have left? My estimated amount of work left, it's 24 hours. And it's good to think this way, right? It's good to think in terms of, I have actually 24 hours where I have to sit down and do work, right? That's not a calendar day. That's sitting in front of a machine and doing work. So then you can start to plan that out. Some of you are very fastidious about your planning, which I think is probably a good idea for student survival. And so you can say, okay, I already know when I turn in P2 that I have, you know, 40 hours of planned work or 60 hours of planned work or whatever the number is. So then you can start to actually put in, oh, okay, on September 30th, I'm setting aside 2 hours. On September 31st, I'm setting aside 3 hours. Right? You can start to think that way. It's good to have these concrete numbers in your head, because we often think, well, I've got this task to do. It's going to take a lot of work and I'm going to get it done. And then it's 2 weeks later and you're thinking, oh, I still haven't done anything on that. But when you're sitting there staring at, gosh, I've got to find 24 hours of real time, then you start to think more concretely about where and when and how that's going to happen, which is the whole point of this. Yeah, it's a large point of this, I should say. Okay, do we have questions about this? I'm not going to promise anything, but if I can actually do the sheepdog game this semester, that would be a good thing. But I'm not sure that I'm going to have even time for 24 hours of actual code work plus the other work. Questions?
What if we have like no idea of how long most of the stuff is going to take since we've
Right.
never done any of it before.
Yeah, and that's the problem. I understand that question perfectly. What I would do is I gave you what I think some of these hours are in the P0. If you look in that P0 deliverable, I don't think I have it up here. I gave you these. And what you could do is just be pessimistic maybe and double them. If you're not sure, it's helpful to be pessimistic. And then if you think, okay, there's no way in that time frame I'll have, with all my other classes, I can get all that done, then you can start thinking about, is there a place where I can scale back what my goals are and still meet the project requirements? I get a fair number each semester of projects that are not literally done, but they've created enough to meet the project requirements, and they've effectively created a framework that works that they can flesh out later on. I think I told you a few semesters ago someone did a car repair manual, and I mean, this guy, you think about it. Think about a car repair manual for all different makes and models of cars. That's only a couple million pages of documentation and data, right? So clearly he wasn't going to get that done in the semester. But what he did is he created a framework where he could go to make, he could develop an input make model and what needed to be fixed, and pull up the parts that were needed and pull up the steps that needed to happen. And he did that for a few things on one or two cars. And I saw him about a year later, and he said he just keeps adding to it and adding to it and adding to it and adding to it. But he got that framework done. The kinds of things that are, for the most part, the things that are going to be the hardest are putting the content, not the functional framework, but the content. So that's usually where most of the time goes. If you've thought through a good project idea, and a lot of people are doing top-down, two-dimensional maze games or run away from zombie types games, or run through the obstacle types games, those I know can be completed in a reasonable time frame. And I don't think it's too far off the mark to say that you, in terms of just coding now, you're at that 40-hour mark.
Is Java capable of like three-dimensional, like first-person type games?
Sure, but you absolutely don't want to do it. You want to use tools that are actually built for that. So raw Java itself is going to give you bare bones graphics, and there's no way you want to try to create all that perspective and ray tracing and all that, who's hiding behind who type stuff from scratch. However, Java and or similar languages are used to create tools like Unity and what's the other one? It's a graph-based one.
Unreal.
Pardon?
Unreal 4?
Yeah, things like that. Yeah, gaming engines and modeling engines, and those are built on top of Java. So what you don't want to do for your project is assume that you're going to have the beautiful graphics and 3D dimensional rooms and things like that. Keep it simple. Then what you can do is take the idea of that game and transport it over using one of these tools. The tools that create the beautiful graphics have taken, dozens or hundreds of developers, hundreds and thousands of hours to turn the raw programming language, whichever one they're using, into actual product. But within things like Blender and Unity, it's the same similar idea. You can create objects, and then you give those objects behaviors, and then they provide physics engines for you and things like that. So yeah. it can be done. It has been done, but you know, there's not 1,000 of us working for 5 years, so we're not going to do it. Imagine your graphics in a very simplistic way.
For games that are like, well, since most of us are doing games, like how do you start the process of building it? Because, you know, the way that you can immediately see results is by seeing the output on the screen. So in your examples, you didn't have screen output until like 2 or 3.
Right, and that's because I'm gonna push and push and push this idea. The thing you see on the screen is not the thing. So in the sheepdog example, we had a white circle on the screen representing a sheep, but that was just representing the sheep. I actually have a sheep class. And the sheep class is the thing that has the sheep attributes and behavior. And that thing never shows up on the screen. What shows up on the screen is literally going to be a Java object that was given to me called circle, and it's in the FX. It's in the FX branch of the Java tree. So then, well, wait a minute. If I can't see it, how can I test it? Well, because I can inject into the sheep class commands, and then I can look at the values of the attributes and see if they are what they're supposed to be. So a test case wouldn't be, as a user, I hit the up arrow key and I watch the circle move up. That's not a good test case. Because, again, the circle is not the sheep. The test case should be, if I inject the command into the sheep called speed up, whatever I'm going to call it, right? And the speed up should always increment by 1, let's say. If the current sheep speed is 4, then the next one should be 5. And if the maximum sheep speed is 5, and I keep calling speed up when the speed is already 5, it shouldn't change. So I can do all that with the math of it, not with the math, you know, I'm going to talk about the math model. We have a math model of a sheep there, right? Location, direction, max speed, current speed. So I do it that way. That way, you know, I can get the circle moving around on the screen. That's actually fairly trivial. You know, I can tie it to the sheep basically. But unless I get the sheep moving right, then it doesn't matter because the circle's not going to move how I wanted it to anyway. So instead, I'm going to work with the math model of the sheep, and I can do all that testing without a GUI.
Is there an easy way to inspect all of the variables and attributes while the code is running in Eclipse?
Yes, and you're going to do a debugging lab, and so you can watch points and things like that as you would expect.
Okay.
And there's another way to go though that Java has, and we don't introduce it in this course. If you're interested in it, you can you know, take advantage of it on your own, but I'm not going to cover it in the course. It's called JUnit testing. And in JUnit testing, for every class, you build a JUnit test class that matches that class, and you do just what I said. You basically build an object of that class, you set attribute values, you perform an action, and then you have a logical test to see if you met the test results or not. In future classes, you guys will get into that, but it's far too much to try to add to this course. But I will mention that it's out there for you ambitious people. Some people, I had one guy 2 semesters ago who started using the JUnit testing, and he was thrilled because every time he made a change to his code, all he had to do was push the test button, and all of his tests ran automatically, and he could verify that all of his classes still worked. So it is useful, but it's a bit of an overkill to have to learn yet another thing in this class. These are good questions. Keep them coming.
I'm not really. Oh,
Yeah.
I'm sorry.
Yeah, go ahead.
I had a question about that. I'm not really doing like a game, but I'm doing like a kind of like a data center for like logs and stuff like that. It's like the scuba diving log.
Yeah, right.
Yeah, I wanted to know how my story should be like for that.
Well, again, think through the functionality of what your product has to do. And then you're going to have things like, as a developer, there are certain things that you need to develop the code. And I think that first user story I did, basically everybody can have that user story. You know, you can steal it from me, I don't care. Because as a developer, you do need that. But then think of, as a diver, what do you want? And as a product developer, so instead of game designer, a product designer, is there something as a product designer that you want to provide to the diver as a service? So you can think of it that way.
Okay, thank you.
You know, start framing those stories now. And, you know, next week we're going to talk about this again. I was hoping I would have time for the examples. I'll go over the actual writing examples next week. But, you know, if you have draft of your user stories and you want to talk about those too, that's all fine. Somebody up here had there we are. I thought I was the only one. No, there's two of you guys doing scuba diving. And now you know each other, so that's good. I've had dive logs done in the past, and the trick is to get a rational reason for inheritance in there. And I think I made those comments on y'all's P1. Right? Make sure you have behavioral differences in there. Other questions? Oh, so in the let me see if I can do this. If I go here, student view, and then I'm going to look at grades, and I think I'm test student. Yeah, I'm test student, and poor test student hasn't done anything. But I do have this P1, and I look here. And view feedback. So when you do view feedback, you'll see whatever you turned in, and hopefully you'll see a whole bunch of crap that I wrote. Does that help? Yeah, you know how when you submit something, there's a comment submission block? It's not in there. I literally, and I don't want to show this because, you know, privacy features. So that when, okay, so did you find them on yours? We're ignoring that, Carly. Okay, so yeah, look at that view feedback, and you'll see right in here, right on the assignment itself, you're going to see a bunch of blue boxes, and then you're going to see comments off to the right-hand side from me. Yeah, I'll stay for just a minute. I'll turn when I turn the recording off. Okay, I'm all set, guys. We're at 50 minutes. So next week, what we'll do is, you know, you already have the writing examples, but we'll talk, so you can look at what's good and bad, but we'll talk about why they're good, why they're bad, and the kind of phrasing that you want to avoid and the kind of phrasing that you want to have. I'm going to stop the recording now. Those of you who are here, if you give me permission, I can pull up one of y'all's comment blocks so that you can see what that looks like.
Can I ask one quick question?
You can.
I was wondering.
Uh-oh, apparently you can't. What happened? You were wondering what?
I was wondering where the estimate for how long certain aspects of the project will be. Like you said that you put that on each of ours, didn't you?
I did not. No. What I did is, if you look in the P0, I'm saying that most projects in the past, my estimate of what your times are, if you look in P0 on that first rubric. So let me see, that's here, P0. The P0 description. Right, this thing. And that's in the P0 module. That's, no, I'm sorry, it's in the assignments. There we go. Yeah, I didn't want to put all the assignments in with the modules for this class because the modules are already goofy enough, but it's right here under the assignments. And there's a P0 assignment that is worth 0 points. There's nothing to turn in. It's just the instructions, the overall instructions for the assignment. Okay.
Yeah, I found it.
Okay. Okay, so Joseph says I can show his as an example. So what y'all want to look for here, I'm going to stop sharing for just a second, again, to protect you guys' privacy. So, whoops. Oh, I'm not sharing? I'm still recording, that's what it is. I thought I turned off recording.